This is a last demonstration. This is our remote field electromagnetic technique. From here on out we'll say Rfet inspection system. This is our multi-channel probe, which has 8 sensors evenly spaced throughout this probe. Basically what this is sensitive to any type of pitting or cracking that might be going on in the tube. We also have a single channel probe, which also we use. That's usually for general wall loss in boiler tubes, heat exchangers. First thing you want to do with this system here is go into your Windows-based software, hit F3 for E+. You're going to see the options for the row, the tube, and the run number. Also an option for the directory. We're going to hit OK. We're going to overwrite this file. And also, as with the Rfet system, you have the plant information which you can add. I'm going to turn the system on. While we get the signal up, basically this is almost the same system as the Rfet, except this is for an ID inspection, this is for an OD inspection. Now we get our signal. Now what you want to do is get a frequency so you get as close as you can to 150 hertz. Now if you're gaining this on the outside of the tube, you want to hit Control G. And when you stick this in the tube, you want to get as close as you can to negative 150. So we're going to insert this in the probe. You want to make sure this is in a good part of the tube. Well, I got 3 pits in here. You want to make sure it's in a clean section of the tube. We're at a minus 138 right now. So what we're going to want to do is we're going to want to increase our frequency just a bit. Control F, let's go to 50 hertz and see where we're at here. Typed in 50 hertz by hitting Control F, hit Enter, hit Control G. Again, we're looking for a negative 150 hertz. Okay, put it in the tube. We're at a negative 159, which is close enough for demonstration purposes. Well, obviously, you could tweak it a little bit. You might want to go down to like maybe 48 hertz. Okay, once you have that in the tube, now, still in a good section of the tube, you want to hit Control G. You want to gain the system again. You do not want to move the probe until it's done gaining. I'm going to pull the probe up. Now, you're going to notice you get like a 166, but when you put it in the tube and you gain it the first time, it's more closer to 150. That's just taking an average of all 8 heads in the probe. Now, if you right click, we want to make sure this is the single channel mode. We want to go in the 8 channel mode. I'm going to click in the 8 channels. You're still in a good section of the tube. You want to Z your probe so you have an even baseline. You'll notice you're going to see the 8 lines going, phase, amplitude, and this is going to be like a side view. Once you have that, you get a good straight signal. I'm going to push your probe all the way through to the end. Before I do that, if you look closely, I don't know how well it's going to show up, but we got 3 different size pits. We have a 92% pit, 76, and a 58% pit. These are 1/4 inch diameter. Keep in mind, probably when somebody asks you what's the lowest or smallest pit you can find, typically we say 1/8 inch pit, 30% deep. In the labs, we've actually seen smaller, up to small as a 16th inch pit. But more likely out in the field, 1/8 inch pit, 30% deep. So once you have your probe through, all the way to the other end, hit the space bar, and as you're pulling out, my scale's on 50 right now, but I just want to show you, you're still going to see these pits. Hit the pause button. And notice this is what it would look like in single channel. This is all 8 channels. Remember, we have 8 sensors going around. Now keep in mind that with the remote field system, we cannot distinguish whether it's ID or OD. But we can give you a location. We can actually go back And by measuring the probe in the tube where the flaw is at, we can give an approximation of from the tube sheet back, how far back in the tube it is. But again, we can't distinguish between ID and OD flaws. Now with eddy current you can do that, but that's for a different demonstration. Now you're going to notice here, if you look, you got three different views here, or three different pits. Again, this is the 92% pit, 76%, and the 58% pit. Hit my F4. Back to the 8 channels, because we have 8 channels in our probe. You're going to see the 3 pits in the first channel, second channel, and in the last channel. You notice the middle channels, it doesn't show up too much. So what that's telling you is when that probe was being pulled through, you had the first channel here, the second channel, and part of the 8th channel coming around. So if this tube was split open and this tube was flat, that's what you'd be looking at. And that would be on this view right here. So imagine this tube being split open, being flat. That's a representation of the pits that we're seeing. That's one of the things you want to keep in mind. Now typically when we go out to do a job, we're just usually pulling single channel, but if we know we're having pits or the customer's having problems with pits, what we're going to do is we're going to want to bring our multi-channel probe with us because it's more sensitive to pitting as opposed to our single channel. Now, when you're doing single channel and it's coming down through the length of the tube, it's taking an average because there's only actually one channel. It's doing the full 360 degrees, but it's averaging as it's going down through the whole 360 degrees. With the multi-channel, it's not taking an average. Each sensor is dedicated to each part of the tube. So as it's sliding down the length of the tube, it's giving you an accurate reading with no averaging for the whole length of the tube. So that's one of the things you want to keep in mind when you're doing that. Now, depending on the length of the tube, the type of material, and the signal we're getting, you're probably talking about 250 to 300 tubes in like a 10-hour shift. And I say 10-hour shift as opposed to 12-hour shift because a lot of times there's going to be like safety training involved. There's going to be analysis that's going to be need to be done possibly on site or back at the hotel. So you basically want to give yourself about 10 hours out in the field pulling tubes and then a couple hours to go back to do analysis. Also important to let the customer know that we don't like to work any more than 12 hours because after 12 hours you tend to get tired and you might miss something that may be critical when it comes to analyzing. That's a short, brief explanation of the E+ multi-channel system using a multi-channel probe.